All right, hello. So, Justin, that's quite a
Hello.
lot. I feel like we need the first round of applause for the wig. There we go, lovely. So, as I was just saying over in the fun track, as we're calling it, it's as if all the tracks aren't fun. Um, I didn't get to see this talk the first time round because I was hosting the other room, and you're in the tent.
Yeah, yeah, I was in the little tent and it wasn't recorded. And so I kind of, when you invited me back, I was like, well, I kind of really like doing that talk. It's one of my favorite talks. So I kind of doing the same talk. It's not the same talk. It's totally different because it's 5 years later, but it's kind of,
Right.
I stole many of the same pictures and things like that. So, um,
Excellent. Well, I don't want to take up too much more of your time, so I'll give you one more applause and then you can kick it off. Here we go. Justin Cormack, everybody.
So yeah, we're going to talk today about exploding steam engines because why not? It's a fun talk, and I I really like talking about history things, and I don't get to do that often enough. I've actually got loads of. If anyone wants to invite me to talk about history of stuff, I've got loads of talks I could talk about that because weirdly people have all these conferences where people want to talk about other things that are not nearly as fun. So if you don't know me, I'm Justin. I work in engineering at Docker. Um, Actually, when Software Circus was started 5 years ago, I had just started at Docker, but it was still secret and no one knew that. But it was so kind of 5 years ago was just about when I started, and it's been an interesting, fun ride at Docker. So we're doing lots of cool things still, but it's been a real interesting 5 years. I'm based in Cambridge, UK. If you follow my Twitter feed, you'll see I often walk to this place. This is one of my favorite pictures of it. This is this is kind of my view of kind of what Cambridge is like. It's basically a science village where you walk into the countryside and they have radio telescopes. This is where quasars were discovered 51 years ago. Not using these telescopes, using some other ones, but that's where I'm from. So back in 2015, yeah, I came along to the first Software Circus, and it was really good fun. This was the party. I presume we're going to have a party just like this later on, with socially isolating DJs, and it was really good fun. And yeah, as I said, I gave this talk, but not many people came, um, and I still remember talking. And every now and again, I mentioned someone, "Oh yeah, I did a talk about exploding steam engines at Software Circus." They're like, "Oh, could I watch it?" And I said, "No, it wasn't actually recorded." So this is not the same talk, but it's sort of the same talk. Um, and really, yeah, as I said, I like doing history talks. There's a lot to learn from history, history of software, history of computers, and the history of totally different things like steam trains. Um, I think this was kind of the picture that inspired me about this talk. This is an advert in the back of a book, for this guy's foundry that will make you stuff, and he's obviously very proud of the fact he'll make you really big wheels. Um, and I was like, oh, this is kind of interesting. Like people were making kind of fun stuff, and they're obviously really proud of it, and they got someone to engrave these big wheels, and there's their portrait. Um, and Steam was really, really important. Steam is eating the world, 1750 edition. Like everything, everyone's investing in Steam. I think we hear about the kind of the railway investments of the 19th century, where everyone went bankrupt. The best time to invest in a railway was when it's gone bankrupt 3 times. It was very much, like the software boom. This is the growth charts that got the VCs excited of the important, people buying steam engines in the 1760s and 1770s in the important parts of the world: Lancashire, Gloucester, Leicester, and London. The steam engine started in England, Britain, and so there's kind of a bit of history that you when you walk around the UK, you run into bits of this history. We'll see some more of those later. And so there was a huge amount of money and investment and everything in Steam, but there were also kind of some problems with Steam. It wasn't like everything was smooth sailing and everyone just made lots of money, and all the steam trains were fine all the time. Things like this happened. So this is what happens when a steam train explodes. Um, the You see that actually steam trains, although, and steam engines in general, although you don't really normally see that, are actually full of this metal spaghetti stuff. Um, this is basically the little tubes that the um, that basically get heated up with and get the steam and turn the water into steam inside them. And there's loads of tubes, and this is the plumbing of the steam age. And these things would just explode sometimes. I mean, not just sometimes, like actually a lot. This is a steam engine exploding on a boat, and obviously the artist who sat here drawing this for the next day's newspaper has carefully drawn all these people drowning rather than helping rescue them, and has spent a nice time drawing, etching all these flames, and it's a bit of a contrast to this one where the artist was really totally lazy and really didn't actually draw very much at all. Obviously, the deadline was you got half an hour to get this into tomorrow's newspaper. Just draw some bits of boat exploding. This one, the artist clearly spent a lot of time sketching all the factories and then stuck an explosion in at the end after drawing the nice landscape and all those things. This is 1881 in Germany. These things were exploding all the time. Look, we've got a photo here. These people are, posing as a morning after photo after their steam engine factory exploded. They were the Cheshire Chair Company in New Hampshire. 1893, these things were still exploding. Like, we've had a whole century and a half of explosions at this point, and it's like, 2 people were killed. This is not really the way we want to run our steam installations. In the end, the insurance probably doesn't cover it, because like these things are constantly exploding. This is a lovely one. This one is actually, you see this occasionally over the internet when people have pictures of steam train explosions. This is full spaghetti mode, spaghetti pouring out of the steam train. It's a lovely picture. Apart from the cameraman didn't actually focus very well, and the steam train's actually out of focus, but the tracks are nicely in focus. But hey, the spaghetti looks great. It's like perfect spaghetti. Bit of a mess. Here's a document which actually just lists all the steamboat explosions in the West. That's a good title for if you're making a Western. I don't think anyone's made that one yet. Boilers exploded, and a lot of people dying. This is not really, a great thing to happen. This is some problem, it's a real problem with steam trains and this kind of whole idea of like, we're going to make a whole economy based on steam, but it keeps blowing up. And then lastly, when I'm going through the pictures, I want to show this one. This is the famous Tay Bridge disaster, not a steam train exploding this time, but a bridge collapsing. This is actually quite a nice drawing of it. The guy obviously spent a lot of time drawing the dog. But this is also famous. I put the famous thing of the world's worst poem. William McGonagall wrote this poem about this Tay Bridge disaster, and it's famous as being the worst poem ever written in the English language. It's quite long and really terrible, and everyone should read it. The poet, obviously being a terrible poet, and B, actually not really knowing a lot about engineering, does explain at the bottom that I must now conclude my lay by telling the world fearlessly without the least dismay that your central girders would not have given way, at least many sensible men do say, had they been supported on each side with buttresses. Excellent poetry there. And it turns out completely untrue, as we will see in a second. But so what really happened was that the Victorians had 3 great inventions that are really totally and utterly relevant to everything we do in software now, that they created in the 19th century. And these really changed everything about Steam. And the first one was testing. So there was no testing before, and you might remember when there was no testing in software. Sometimes there's still no testing in software. This great thing saying facts, not opinions, which is something that every door should have above it. This is actually from the Testing Museum in London. It's the Kirkcaldy Testing Museum. It's by the Tate Modern, and you should go and visit it when it's open again. And their slogan was, Kirkcaldy's slogan was facts, not opinions, because he was like, he actually was brought in to test why the Tay Bridge fell down. He wasn't like, oh, well, you should have put some more girders at the buttresses at the side. It would have fixed it. He actually tested it properly and found out what the real reason is, which we'll look at in 1 second. Software, we test it. We sometimes test it. We tested a bit. Our tests are not necessarily really great. Kirkcaldy built this gigantic machine, which is in the testing museum. And basically, this is a machine it's bigger than actually this picture here. Even it's like gigantic. It's the whole length of the room. And basically, he took girders from the Tay Bridge and tested how they broke and discovered that they hadn't really been cast very well and they had faults in them. And basically, they would break really easily. And that's obviously what happened. So, he didn't, like the William McGonagall's poem, just come up with some stupid opinion, which is what people have been done before, but he did tests. And after that, far fewer bridges fell down because people would actually test the girders before they built the bridge out of them. And so, testing was an amazing thing. Then the next invention was really amazing. This really was what stopped things exploding. Well, largely stopped things exploding, was the safety valve. So the safety valve, it's a really straightforward, sensible device that basically, if the steam pressure gets too high, it lets off steam. That phrase has gone into the English language, letting off steam. That's what it's from. It's from safety valves. And, safety valves were basically, made compulsory on steam engines. There were laws about steam boiler explosions because they were killing lots of people, and they basically had to be, we had to have tests, monthly tests of your safety valve, and so on. And you basically, there was inspection periods, and there were safety valve inspectors, and basically, as soon as if the pressure rose, you shouldn't actually you shouldn't actually let the boiler explode. You should actually just let off a bit of steam and let it gradually settle down. And we're still not actually very good at that with software. Software tends to do things, when it gets overloaded, it still often just tends to crash. I've found there's a lot of cartoons about the killer, which is the next thing that kills your container or your process or Firefox or whatever when something uses too much memory. We don't write programs that, generally, let off steam when they're running out of memory and reduce the memory allocation much, things like that. We're really bad at kind of resource allocation, dealing with resource limits in programs. Programs just tend to crash when they get overloaded, or they really, really, really slow down. Latency goes through the roof. We start swapping, all sorts of terrible things. Virtual memory is not real memory. It doesn't behave the same way. So we're not really yet very good at dealing with pressure in software systems. And there's a lot to learn from safety valves. You should test your software when it's overloaded. Actually, in the original version of this talk, I actually did a little demo of this and tested some software to destruction and found out how poorly it behaved. It's the sort of thing that people just don't do. People test under normal kind of load, and they don't really, they don't deal with the fact that the software shouldn't just crash if you overload it. And that's kind of basic stuff that the Victorians worked out with safety valves kind of pretty early on, because it killed people. But software doesn't kill people, but software could be way better. And then the third thing that the Victorians invented, well, actually it was invented even pre-Victorian, was the governor. And the governor is an interesting word because it comes from this ancient Greek word called Kubernetes that you might hear a bit nowadays. Yes, the Victorians invented Kubernetes. So the governor, in case you're not really sure what it is this is the traditional ball governor. This is actually the one on the left is actually a monument to the governor that we have in England. I must go and see it one day. This picture's from Wikipedia. It's somewhere up north, the Watton Bolton governor, more his giant balls. What happens, you might have seen one somewhere, but it's the diagram in the middle kind of shows it. Like the balls swing out as this thing is vertically spinning around, and the balls spin out, and the faster it spins, the higher the balls raise up, and then as they raise up, they cut off a bit of the steam, so it ends up in a equilibrium. If it spins faster, it cuts off a bit of steam. You get a feedback loop, and it stabilizes at constant speed. It's basically it's rate limiting. It's basically, as we'll see in a minute, it's basically the foundation of how you make things actually run smoothly. The one on the right is a different model, but very similar kind of design. And as we'll see, Kubernetes is actually totally, in some ways, inspired by this, but in some ways also kind of we need to use this a lot more in software. There's a thing about the company here. I've actually got the book. This is from. Let me show you. I can show you the book. This is from. I've actually got the green screen on, so this book is green and now looks like the background, which is hilarious. But this is a book called I should turn the green screen off, but I'm not going to. The Catechism of the Steam Engine, and it's basically it's a book by the New Catechism of the Steam Engine. It's by a steam train obsessive, and it's got a section on the governor, and the governor is the ruling spirit of the engine. And basically, what it says is really kind of interesting is that if you're running things by hand, if you're performing things by hand, if you're basically running manually in production, then you don't need a governor necessarily because you can control your software by hand or your hardware. But if you have a factory, a data center, anything like that, where you're really, you need to actually, run the thing reliably, then you need a governor, which will automatically vary the supply of water, gas, or steam, as the case may be, in proportion to demands made on it, and to keep the speed of rotation constant under varying loads. So, we're load balancing, we're controlling the load, we're dropping excess load, we're running our software smoothly at a rate that it can sustain. We're not overloading it. We're not going into the safety valve area, but we're keeping it, constant and behaving well and inbounds as the as the workload changes. As the workload changes, we'll adjust the performance. And this is kind of really really important for software. The kind of most famous invention that came in the early 20th century, really early on, actually, in 1913 or so, I think it was, 1914, was the autopilot, which basically uses the same principle as a gyroscopic governor for an aeroplane. This is a picture of Lawrence Berry, the plane on the left. This is the people in France inspecting after his amazing first demo of the autopilot, where he flew over the audience 3 times. The first time he just took his hands off the controls and said, "Look, no hands, look, Ma, no hands," kind of thing. Second time he went over, he climbed out onto the wing of the plane, and the autopilot kept the plane steady as he walked along the wing. And the third pass, both him and the co-pilot came out, one onto each wing. They flew over, no controls at all. Basically this thing could just fly a plane. Even if the plane kind of wobbled, it would bring it back into alignment. This is the principle of the governor and stability. And over time, this, became really important. In 1868, James Clerk Maxwell, the famous physicist who invented electromagnetism, which is how you're seeing me now, basically wrote the first paper on how governors actually work and the maths of the governors. And we got to the PID controller, which is proportional integral derivative, which is basically dealing with how to control things. The governor is really a proportional controller, but if you're controlling things with more delays and things, you need the integral and derivative as well. There's a brilliant talk from QCon New York 2019 by Colm, as AWS about PID loops and keeping these stable. This whole thing is actually turns out to be one of the hidden secrets of Amazon and the cloud providers. This is how you run software ultimately, so it's totally as reliable as possible. This is the sort of stuff that like people far too few people understand when they're building software. I've got a picture of TCP on the right. TCP is the other kind of famous example of a feedback loop, keeping things keeping things stable, working out how much bandwidth there is, and then keeping them stable. But this is a secret. This is almost a secret. Like, it's something that people don't talk about. I talked about this in my talk 5 years ago. There wasn't, as far as I know, almost nothing talked about it till Com's talk last year. I highly recommend this talk. It's really, really, really good. But this is the kind of stuff that the Victorians discovered to build their steam trains, but we are not really using as much in software. Software can learn a load of stuff from steam engines. It's not just a kind of thing that happened in the past. Like the control testing and safety and not exploding and building reliable software is something that we're still not very good at. And all this stuff was kind of solved in the past. So it's really, really, really interesting to basically look at history and take it and think about these things in a modern context. So that's what I had to say. Thanks for listening. I'm really, really happy to speak at Software Circus again, and happy to hang out all day because it's always great fun, and really love talking to you. Thank you.
All right, thank you, Justin. That was fantastic. Let me find my sound effects. Very good indeed. I've been pushing people for questions. Unfortunately, none of them are about technology. So let's step through a couple of them, and then I'll get to technology. So Jamie asks, why do you never age? And Adrian suggests that it's either because you are Dorian Gray or Connor McLeod. I think Connor McLeod is the Highlander.
Yes, I think you should see the picture in my attic.
That was actually in the chat. All right, good. Staying with the aesthetics for some reason, Andrea wants to know where you got your hat and wig combo from.
I just found them somewhere on Amazon. I think it's the party store in the that I got them from. I kind of like the fact that I have the old Victorian Alice in Wonderland pictures in the back and the Alice in Wonderland from the movie in the front, because to mix up the history and the present day, it seemed appropriate.
Great. We've got finally one serious question here. I mean, I like that we've basically got people into the mood where they feel like all the questions.
Absolutely, that's what it's for.
I feel like that is what good looks like here. However, Paul Scott says, very good talk. What's your favorite example of a PID controller used in software?
Well, I think that there are not very many public. I think studying TCP is something that everyone should do, or because it's like a foundational technology that like people tend to understand, like SYN and ACK and the kind of handshake, but people don't actually look at the bit of TCP where it actually works out like how much bandwidth they've got, deals with like changing your internet connection, going up and down and things. Those parts of it are actually really interesting. And there's been a lot of work on that. Part of the work with Quick, which is the new kind of TCP replacement over UDP, is to make it easier to experiment with different, quick start, slow start, all those kinds of things. And then there's, data center TCP, which is designed for like faster, lower latency connection, things like that. There's loads of really interesting work on feedback loops there. Colm's talk, I totally he has some examples from things in AWS. There's not nearly enough stuff actually in published software. I think it's one of the reasons why it's important to talk about. RSocket is also an interesting protocol, which basically was originally designed at Netflix for dealing with these things. And it does feedback kind of from the application point of view. And I think it's a really good thing to look at as well.
All right, thank you, Justin. We've got a few more questions, but before that, I want to explain what's coming up next. First of all, apparently people are having a hard time finding the sponsor tea rooms. If you go to Brella and look at the left, you'll see people, schedule, stream, speakers, and then sponsors with a little icon of two people shaking hands, which I can't do with myself. In there, you'll find all the sponsors. If you click on the logos, you'll be able to see that some people are already in there. I can see Mo from Packet. I recognize Ricardo from Container Solutions. There's Rancher people there. I also see that Liz Rice at 12:15 is doing a live Q&A if you want to go over to the Active Security booth. And I see a bunch of other people hanging around in there. So go in there, have a chat. Some of them have free things, like Liz. I'm sure many of them have free things. I don't know what we've got at Packet, but I'm sure we've got something that's of value.
As well as great servers, obviously.
Oh yeah, right. Probably, yeah. If you've got a good use case for some bare metal, let them know in there, and we will hook you up. All right, back to the questions. We got about 90 seconds left, so let's see. Probably just get through one. Adrian Moa asks, what techniques can we use to reduce memory pressure in software? And then adds, I assume the reason we don't do it is because it's not straightforward, but it's not something that I've ever tried.
It's really, really hard. And I think part of the reason it's hard is Linux has had this idea that generally it will pretend it's got infinite memory, and it'll do memory overcommit. And so it'll always tell you there's memory. So you'll never stop being able to allocate memory. And also programming languages are not very good at this. So it is really hard. There's a whole talk in that. Yeah, it's definitely not easy. And you really have to understand how much memory you're actually allocating, and just not allocate memory outside of a controlled fashion, which is actually very difficult in modern languages because they're all designed to pretend it's not a problem.
Right. Thank you, Justin. Incredible talk. I'm glad that I finally got to see one version of it after missing it 5 years ago. Coming up next, we have a 15-minute break, but it's not a break. You can go over to the fun track. So in Brella, get the drop down, go over to the fun track. Some of you who are there first time around will remember that we had a live band walking around the big field playing music for us. That band was called Ivan Campo, and they're with us today to play some music and to talk to us about all the things they've been up to in the meantime. Before we go away, let's get one more virtual round of applause for Justin. And thank you very much, sir.